Welcome to this webcast on the curriculum in design technology. This webcast is brought to you by Primary DT and is written and delivered by Lawrence Keel. In the previous webcast, we looked at the national curriculum requirements for design technology. In this webcast, we will see how the national curriculum is translated into a school curriculum and scheme of work. This diagram models one approach to delivering the national curriculum as a school curriculum or scheme of work. We can split the knowledge that the children will learn into two key areas, that of disciplinary knowledge and technical knowledge. The disciplinary knowledge focuses on how the subject works and the creative and iterative processes of designing, making and evaluating. Linked to these processes is the importance of children developing a technical vocabulary that allows them to articulate and discuss their learning, understand more about the subject and to conduct their own independent research. Such is the importance of vocabulary that one of our webcasts will be devoted entirely to this area of learning in design technology. The final area of disciplinary knowledge is the study of designers and designs, because if you want to know how a subject works or to get better at the subject, then study people who do the subject well. Technical knowledge includes developing knowledge about products, knowing how they work and how things are made, and can be divided into 6 strands of learning: cooking and nutrition, materials and textiles, structures, mechanical systems, electrical systems and program systems. For the purpose of this model, technical knowledge also includes the practical knowledge, skills and techniques associated with each strand of learning. And this is that same curriculum model translated into a model that shows how the curriculum can be implemented as a progressive scheme of work. In practice, electrical and program systems are taught towards the latter end of Key Stage 2. So therefore, through studying the 6 strands of learning, children acquire the knowledge and experiences of designing, making, evaluating products, while also gaining the technical knowledge, practical skills, vocabulary, and know about the designs and designers associated with each strand of learning as they move from year 1 right the way through to the end of year 6. And again, we can take this model further and translate the strands of learning into actual projects that are taught each year. This model of long-term planning is one which is common in many schools where design technology is taught once per term. Such is the importance placed on cooking and nutrition within the national curriculum that a unit of work is taught each year that focuses on cooking and nutrition. Materials, and this is often a textile-based project, is taught every other year as are projects focused on building different structures. The final strand of learning has the common thread of systems, where children include either a mechanical, electrical or program system as part of their product. It would be expected that these products would be more complex as the children get older, and it is likely that products developed as part of the electrical and program system projects would also include elements of children's learning about materials and structures. What follows now is an example of how that long-term plan is translated into actual projects where the children design and make a quality product. Building on their experiences in early years, children begin their learning journey in cooking and nutrition by designing and making a fruit salad, providing opportunities to learn how to cut and prepare different fruits. In learning about textiles, they design and make a simple hand puppet by sewing together fabric pieces using the running stitch. Their first experiences of using a mechanical system could be to design and make a celebration card with a movable part. This presents opportunities for them to learn about sliders, levers and pop-up mechanisms. Moving to year 2, the cooking and nutrition unit extends children's food preparation skills by teaching them how to grate vegetables and how to use a juicer when designing and making a rainbow salad. In the structures unit, children are introduced to frame structures and joining different materials when designing and making a model playground. In Year 2, children are introduced to a different mechanical system, that of the wheel and axle, when designing and making a Teddy Explorer vehicle. When children move into lower key stage 2, the expectation is that they should learn to cook some simple recipes. This could include designing and making a bread product that can be shared by a group of friends. In designing and making a cushion, children are building on the knowledge and skills that they learnt when making puppets, but learn new knowledge about decorative techniques, how different fasteners create temporary fabric joins, and learning new stitching techniques. Designing and making a mechanical book page extends children's knowledge of levers by linking them together to create movements on a book page. Having baked bread in Year 3, the seasonal tart project teaches children how to make pastry with either a fruit or vegetable filling. This provides opportunities to revisit those food preparation skills learnt in Key Stage 1, as well as learning about seasonality in food production. Having learnt about frame structures when making a model playground, in this unit, children are introduced to shell structures, different techniques and materials to make shell structures, and how they can be joined together when designing and making a desk tidy. When designing and making night lights, children have the opportunity to apply their knowledge of simple circuits from science lessons to create a product that uses an electrical system. As children progress into upper key stage 2, the products that they are required to design and make are more complex and may involve applying knowledge from several different strands of learning in design technology. In Year 5, children might design and make a pizza that promotes the healthy eating messages from the Eat Well guide. They will apply their knowledge of making bread from lower key stage 2 to make the pizza base and consolidate their food preparation skills when making the tomato sauce, grating the cheese and creating other toppings for their pizza. Children will design and make a complex textile product when designing and making a tote bag. This provides opportunities to learn about fashion design, a range of decorative stitching techniques, and designing a product for a specific purpose. Year 5 is likely to be the first time children encounter using program systems when designing and making a model fairground. As well as applying their knowledge of structures and pulley systems, they add an electric motor that they can control using block code. The final project in the cooking and nutrition strand of learning could be quite complex in challenging the children to design and make a 3-course meal that includes a main meal, salad starter and a fruit-based dessert. This provides children with the opportunity to recall and apply their knowledge from previous units of work on cooking and nutrition. In the example here, they design a 3-course airline meal. Designing and making a marble run toy challenges the children to create a prototype design by applying their knowledge of both framework structures and shell structures. The final project in this sample long-term plan involves a program systems to design and make a digital decoration for the school Christmas tree. Children use their textile skills to create the decoration and then add a BBC microbit that they program to respond to both the buttons and also changes to the environment. This concludes this webcast that has looked at turning the national curriculum into a workable scheme of work for design technology. Part 3 of the series on the curriculum in design technology will look at some other curriculum considerations in design technology before moving on in webcast 2 to look at design technology in the early years. All units of work, product examples, teaching ideas, photos and learning activities featured in this webcast have been taken from the Primary Design Technology Scheme of Work. The Primary DT website provides information about the content of over 50 units of work that have been written as part of the Primary Design Technology Scheme of Work. Each unit is available for immediate digital download from the website. Each unit of work is priced at £10 and includes medium-term planning, lesson presentation slides, a knowledge organiser and all the digital resources that are needed to teach the unit. Discount prices are available for schools who wish to buy multiple units of work to create their own scheme of work or to supplement their existing scheme. The primary DT website also contains many resources and guidance that can be downloaded free of charge.